Climate underpins the design, and we can now use that data to target specific issues and metrics that impact master plan design. Humanity is currently in a second wave of urbanization, with the bulk of city growth coming from developing countries. Urbanization is also taking shape in developed countries, such as the US and Canada. In this case, people are seeking to remain in city centers, close to jobs and entertainment options. The established tradition of buying a house in the suburbs is being disrupted as people seek to avoid long commutes. This allows for efficiency gains as density increases in the city centers. This also means that outdoor urban spaces are of prime importance. Creating vibrant outdoor areas which service residents year-round is, in most cases, an attainable goal. To that end, thermal comfort is quickly becoming a key factor in master plan design, not only in hot climates like the Middle East, but also in North America and Europe. Thermal comfort is a complex problem. Everyone perceives thermal comfort differently, but there are several key parameters which influence our perception of thermal comfort. Environmental variables include wind speed, temperature, relative humidity, and radiant temperatures, such as solar radiation and hot or cold surfaces. There are also subjective factors, including clothing and activity levels. Other parameters like gender, height, and health also play a role, but are harder to define. Additionally, acclimatization is important. A local might perceive comfort quite differently from someone that is visiting. These parameters can be combined using a combination of thermodynamic models of the human body and human perception of comfort, obtained from surveys into a thermal comfort metric. The metric shown here, SPMV star, defines a neutral condition with a value of 0. As one moves up the scale into positive numbers, conditions are increasingly warm. Moving down the scale means conditions are significantly cooler. A holistic approach combines solar installation data, a local climate history, and CFD simulations of the wind microclimate to predict pedestrian thermal comfort at scales ranging from single buildings to entire cities. This helps designers create comfortable pedestrian spaces that promote walkability. This type of approach can lead to a deep understanding of the conditions within the site, completely understanding the environment around any project. Taking advantage of the site and climate to achieve a better design, use of thermal mass effects, landscaping and canopies, inclusion of active measures such as forced air systems, fans, evaporative cooling, and so forth. We can also make the performance goal oriented by targeting thermal comfort, shading levels, natural ventilation potential, energy profile, walkability, and even potential for rain infiltration. So, for a project such as this one in Berlin, Germany, it could mean understanding the wind regime, shading levels, and solar exposure of the pedestrian realm, combined thermal comfort for various times of the year and day, renewable potential such as rooftop wind energy, or solar energy. Results can also be used for daylighting, plant growth, etc. There are a variety of other metrics. Air quality has clear metrics provided by EPA, World Health Organization, and so forth. We must meet these, although master planning rarely looks at it. Acoustics, noise, and vibration, while there are standards on what is reasonable, very rarely are standards applied in design. Glare and visual comfort tends to be descriptive on building facade. And finally, odor. Yes, it is possible to score odor.
Coming up in Module 5, Enhancing Design.